Time for another draftphysics.com, debatephysics.com, also video presentation. So I'm going to do a relativity type video, time dilation nonsense. Not my favorite subject, but because everything they do is so convoluted and complicated. It's all this silly math crap, and frankly, it is silly math. And I'll attempt to explain some of that. And so there's this video by the stupid Claude Rousseau, Val Rousseau, whatever the fuck his name is, the shithead from the Catholic University, Xavier. Anyway, and he's just this obvious clickbait. I mean, just so tacky. I mean, this is supposed to be physics, should be something real, not a cartoon, but no, that's all they can produce, frankly. So his video is all math, though. Okay, so in spite of the icon that seems, touchy-feely, there won't be anything touchy-feely in the video. So, it is just bullshit, clickbait. Anyway, it's as dry and uninteresting as you could possibly make a conversation about the physical universe, frankly. So I'm not going to bother playing it. I'll show it, I guess, and and then I'll just go to the better explanation, frankly, of what goes on with this whole subject of GPS and time dilation, and it's all a pile of crap. Simultaneous things in the universe are simultaneous. Your perspective is irrelevant. When you see the photons, couldn't mean a damn thing to a rational person. We know the moon's a second away. We're not seeing the moon right now. We're seeing it a little later. Jupiter's 8 minutes away or something. We don't see it now. We see it how it was 8 minutes ago. So the stars, it's billions of years ago. Blah, blah, blah. We are smart enough to know all that crap. We're not going to be fooled. That if it blows up today and a big fireball flies out of it, it's supernovas. We know it didn't supernova today. It's just too silly to even have this conversation with, again, adults. But anyway. All right, so first I have to get rid of this image. All right, and I'll do that. So this is his web video, and it has a suitable advertisement from YouTube, of course. I saw one. I wish I screen saved it. I actually saw it twice, and it's a woman actually doing a blowjob, and it's like selling solar shingles or something. I don't know what the fuck. I can't remember what the ad was for, but it was literally. You couldn't miss. I mean, it's like, what the fuck, YouTube? Oh, the world is just, civilization is turning into absolute shit. On this very video when I played it, an ad came up and it starts with the fart sound. It's just so funny. I mean, it's right in the middle of his physics. There's farting and then people playing with people's hairy abdomens, and it's just disgusting. It's just so funny that the human race has allowed this to be how it functions, this lowest common denominator. We can only sell crap to morons, and so everything has to be produced to sell shit to morons. There's no intelligent content anywhere. Oh, it's just so depressing. Anyway. Alright, leave us get rid of that, because we won't bother with that. Alright, so the first thing you got to know is atomic clock. So I'm just going to give you the simple version. I don't know the very, very complicated version. But the idea is it's about initiating a vibration in atoms. So you have an atom of cesium is the most common. And let's just say it's got 4 electrons. We're not going to bother with a whole complex thing. But the idea is all these atoms are connected to each other. And I believe you have to basically vibrate the whole substance. So we're talking about a resonant frequency, essentially. And so what you do is you expose it to light, ultraviolet or microwaves, whatever, and you vibrate. You push energy in. And the idea is this is essentially a closed vessel, like a instrument, like a trumpet or something. It's a fixed size, and so it'll make one note. So there's one preferential frequency at which all of these electrons will vibrate. That is where you'll add energy and the system will keep adding energy at that frequency. So you're basically taking kind of a noisy light, light that's not a perfect frequency, and the cesium atom is going to make it a perfect frequency because it's a very tight system of matrix of atoms. There are specific distances from each other, and the vibrations can only vibrate at certain frequencies, and it's a very specific frequency, and so that's your clock, and it does that 1 billion times a second. These little electrons wobble. All right, so that's the nature of the clock, is that it's just a vibrating electron. Okay, electrons. All right, so what you're getting out from the atom is something that's a pure frequency, and you're putting in kind of a noisy frequency. That would be my simplification. So the timing is that you're taking a noisy, not precise, frequency, and you're getting a very precise one back out. So you're putting in a dirty photon, let's say, dirty photons, and you're getting back very pure, always the same frequency photons. All right. So then the whole GPS thing, again, is for most people, they don't even understand that the satellites, moving, say, 20,000 miles an hour, it's probably a little faster than they are going, but whatever. And we're here on the Earth going 1,000, okay. And the difference is the gravity. So they're far enough away from the Earth where their gravitational pull is smaller than ours on the surface of the Earth. And you could understand that what happens to you when you're on the surface of the Earth, right? You think you're just sitting there, right? You're just sitting, I could do butt cheeks. You're just sitting on the Earth, minding your own business, and that's not what's happening, though. What's happening is the gravity's pushing you into the Earth, and the Earth is physically pushing you back. So gravity's pushing you in this unique way for gravity, right, where it doesn't hit your surface. It hits everything. The electrons and protons all are hit by this very dense force that just right through you, okay, through all the empty space between the atoms, and it's just hitting the electrons and protons. And so you don't feel it because your electrons over here are going to get moved just as much as the ones here, just as much as ones everywhere. So the down force is constant across your whole body. When the Earth pushes you back, it pushes you back ass first, right? So you feel it because it's a physical contact, matter against matter. It's not force against matter, it's matter against matter. Now, matter against matter is force against force, but obviously it's very localized. So it's a very different transfer. It's not going through you. It has to push, and the push has to go through your whole body. So it moves your spine more than it moves your gooey parts. So there's lots of uneven movement, and that's why you feel it, is because there's a lot of uneven movement. So you feel the push back, but you don't feel the push in. But the fact is that's what you're doing. You're oscillating. Okay, so, and even though they say it's 9.8 meters. I have another video of that. It's just so funny. Per 1 second. Okay, and they say second squared, which is just absolutely nonsense, made up, fictitious crap. But anyway, this is what the real Newtonian formula is 9.8 meters per second of velocity over 1 second. Now, 1 second's a long time, but obviously gravity's not coming in second chunks. It's not a 1 second. It's every billionth of a second. It's doing exactly this, except this number would be, 0.000000064 every billionth of a second. Something like that. Well, I guess it'd still be 9.8 at the end. It would just be a billion worth of zeros here. So let's just put 6 or 7 zeros. But that's what it's doing every billionth of a second. It's happening every billionth of a second or every trillionth of a second. Gravity's pushing you constantly. So it's not in 1 second chunks. So understand that you have a frequency in the sense that gravity pushes you in and you're definitely getting pushed back up. And that's happening all the time. Right now inside of you, there's stuff moving up, electrons and protons, and there's stuff moving down. Right now, it's happening to you. All right, and so you can understand, if you go back to the cesium atom, that if it's all about a vibration, that if you're vibrating the cesium atoms, all right, that's going to be part of this resonant frequency, that this is going to be part of how the atom is going to resonate, and you're going to change that frequency. You're going to change the timing of that frequency based on how much gravity you're in. So if you're in a lot of gravity, you're doing a lot of vibrating. You're in less gravity, you're doing less vibrating. So obviously this would be the change in the time. And the trick is this clock on Earth, this is the one going slower. All right? The one here on Earth is the slow one. That's the one time dilated, not the satellite, the one on the Earth. So we know this is about, substantially about gravity and what gravity is doing to the clock, and not so much about velocity explicitly. But you could argue that obviously if you're vibrating more, and you were going 1,000 miles an hour, but you were vibrating, you can understand that this is your actual velocity, all of this jiggling. You have to count that whole path. Basketball players going one speed, the basketball is going a much higher velocity because it's traveling a lot more distance. So those are all understandable arguments, right? So you can't say that these are indestructible clocks, that there's no way there's anything you could ever do to a cesium atom to disrupt its vibration frequency, when obviously they haven't proven that. So until they can make synthetic gravity, I suppose, they're out of luck and sit there and say, oh, it's just impossible that this isn't being just affected by gravity. The gravity's an actual force. It's a mechanical force. And the fact is that mechanical force is disrupting the function of the cesium excitement. When you're exciting the atom, you have to do it in the context of what the atom's doing. And if the atom's doing this versus doing this, that it's going to excite with different frequencies. That it's going to have a different resonant frequency. So it makes every bit of sense to me, frankly, okay, to understand that these aren't indestructible clocks. And that's all that's really happening, is you're just breaking the clock. You're not breaking time. All right. So this silly argument is the triplet thing is just saying, oh, let's just add another player. So you got, one sister, you got another sister you're going to shoot this way, you got another sister you're going to shoot this way. That's it. Okay. And then you're going to pretend that if this is half the speed of light, that they're traveling, that this one, when it looks back over to here to see this one, that one would be perceived by your eyeballs as going the speed of light, because you're leaving at half the speed and she's leaving you at half the speed. So obviously that would look like if it was 50 miles an hour this way and 50 miles an hour that way, it will look like 100 miles an hour. It'll look like the other person's going 100 miles an hour. Well, we're smart enough to know that what it looks like is bullshit. Okay, that doesn't mean anything. We know that with trains. We know that with lots of things. We can perfectly understand that, I can have a pickup truck and I could be going 50 miles an hour down the street, and I could just throw a baseball, and if I throw it just the right speed, it'll fall straight down. Am I going to be fooled and think, that I don't understand that all I've done is decelerate the baseball? I mean, I thought I was accelerating it, but I wasn't really accelerating it. I was decelerating it. And now I've stopped it, and that's why it falls straight down. Duh. We can understand this. Why are we going to pretend that what we see means that's what happened? Because it's not. Again, two simultaneous events, like this sister blows up at exactly the same time as this sister blows up. It doesn't matter if I'm closer to this sister that all of a sudden she blew up first. I know that didn't happen because I know about what distances are. I know about how the speed of light is this fixed thing and you're just shooting it. So I thought about how to do this experiment. Well, let me do the Lorentz transformation first. So that was in his video. And all it is a factor to prevent things from going faster than the speed of light. So they just create a catch math where they subtract something to oblige it never to go over 100. So it always has to be less than 100. It can never be 100%. And, Einstein stated this like it was some sort of fact nobody knew, that you couldn't make matter go faster than the speed of light. And he's saying it's because it gets insanely massive and you can't push it anymore because it's insanely massive. And so I'm just going to give you a simple illustration that shows exactly the same effect mechanically. It produces exactly the same outcome, all right? But it doesn't have any of that woo in it. It doesn't have any declaration. It simply explains perfectly why you can't push matter faster than the speed of the pusher, okay? Because I'm going to tell you it's a pusher. So if you understand that all the stuff going the speed of light, that is all the forces, like photons and gravity and magnetism, and in cases electricity, think of it as just a siphicus, okay? And when it's flying free in the universe, it's going c. It's going the speed of light. And all there is these two kinds of matter, electrons and protons, and that's all there is. So I'm telling you, that's all the universe. There is no neutrino, there's no quarks, there's no antimatter. All of that crap is just one of these things hitting something and causing an effect, and the physicists are saying that effect was caused by a quark or something, when no, all it was caused by was an electron barely hitting a proton, or deflecting at a 30-degree angle, or some kind of thing like that. It's just an amount of momentum being transferred. Now, part of why they can't get any of this physics right is because they accepted this silly 1/2 mv squared. So every time something moves or something happens, they make up this preposterous amount of energy that the thing that caused it had to have, because they're thinking this v squared crap is real, and it's not. So there is no neutrinos because they're miscalculating how much energy an electron ejection actually is. So you don't have to make up any extra energy because they're fooled into thinking it takes 200 million joules of energy to move the spaceship, when no, it only really takes 150 because that's all that's going to be exchanged is the momentum. This v squared crap just makes messes. It doesn't fix anything, it breaks everything. All right, so anyway, you have this simple relationship. So let's just, we'll just deal with the electrons. We won't bother with the other. And so let's just say this siphicus is, okay, in the force, all they can do is they can reflect, they can absorb, that is, they can stick, or, for a charge, they transition. So we're not going to bother with any of that stuff either. So we're just going to say the siphicus basically can stick to the electron. So you can understand that if the siphicus is pushing the electron, it's got now it's more mass. So let's say this has a small mv, it has its own mass, okay, and it has a velocity. And now it adds mass. We already know what happens when mass is added. I have to conserve the mv, so I have to reduce the velocity. So the velocity has to go down based on how much mass I've added. And it doesn't matter how many of these siphicuses I add now, right? So no matter how many I add, each time I add one, he can only increase the mv. That is, he makes his contribution, but I'm always pushing this extra. So they go the speed of light when they're not pushing anything. But as soon as they're pushing a dust particle, they have to go slower than the speed of light. Now, 3 of them are going to push pretty fast. Obviously, with each addition, I'm going to go a little tiny bit faster, a little tiny bit faster, a little tiny bit faster when I have more and more helping push. But they can only go the speed of light. And as soon as they have to push any piece of any single, even a single electron, they can never go the speed of light again. So as soon as I add any extra burden, they're done. But they can't push faster than the speed they're going. And if they're carrying more matter, they're done for. So it wouldn't matter if I had 1 billion of them here. It still would be less than the speed of light. So that's the limiting factor. The fact is that the speed of light is based on the speed of the pushers. The pushers move at the speed of light. The thing getting pushed can't move the speed of light because it can't move as fast as the pushers. It can only move at best a little bit less than, a tiny bit less than, but never the same speed, because this is always going to be a burden. It's always, you run your fastest mile, right? As soon as I add any weight to you, you'll never run that fastest mile again. The same thing happens here. That's the Lorentz transformation right there. That's their little catch. Okay, so it's a nice simple mechanical reason why that happens. Why you can't make something go faster and faster and faster. Even though you're adding more and more energy, you're only getting a tiny difference in the momentum. Because you just can't go any faster. Okay, I mean, you can go faster, but you can only go faster in tiny amounts. So the first one pushes, he pushes a lot. The second one pushes, he pushes a little less. Third one pushes a little less. Fourth one pushes a little less. Fourth, it just gets less and less added to the total because you're dividing this mass over all of these pushers. So it becomes a smaller and smaller increase in the mass being pushed. Sorry, that's not very centered, but those details can't matter to serious people. Anyway, all right, so I thought that was important to throw in, that you don't have to think of this as complicated. The sources of these equations doesn't have to be abstract and non-tangible. It can be quite tangible. You can grok it quite easily why there would be such a circumstance. And I'm saying that simple circumstance, that the force carries the motion and the matter is dead, and it has to be pushed as if it was a dead boulder. And that simple understanding fits the facts perfectly. Okay. So the other thing, so once you do this, let's say you were doing this experiment, if we could do it, right? There's lots of rules here that just say, well, how the hell you know if you can even make a photon when something's moving the speed of light? Because a photon is a process. A photon's a big thing. 500 atoms of polarization. The distance between the frequency, the wavelength, if you look at that distance, you can fit 500 atoms in that distance. So it's not a little tiny thing. It's kind of a big thing. It needs to hit a few atoms to make something happen. It has to hit more than one electron. So when they draw that picture of an electron shooting a photon, it can only shoot a piece of a photon. It can't make a whole photon. Not possible. All right, so here's the example. So what if these twins, let's just make them spaceships instead, and put clocks in them, but whatever. And you shoot one this way, okay, and you shoot one this way. All right. And so my argument is, if I could put a very powerful laser on them, right, then well, see, lasers aren't, yeah, it might still, lasers won't work. You need to have a light that does disperse. I mean, lasers do broaden with distance, so I guess it would still work. They spread. And the fact is you could tell that distance, you could measure distance, just like an interferometer, by how much the light is spreading. So the more spread the light is, the weaker it's going to be. The fewer photons you get hit by. And the closer you are, the more photons you get hit by. So that'll be the simple rule. So if they both have these powerful lasers and they can detect each other's laser signature, then you know exactly how far away they are. Okay, so as they're moving. And obviously the frequency, okay, they'll see is going to be redshifted, because as they're shooting their photons, they're moving. Okay, so the distance they'll travel between the burst of photon is going to keep increasing with their velocity. So until they reach some kind of standard velocity. But the fact is they think they're producing a frequency at a set rate, but the rate is going to be completely dependent on how fast they're moving and whether they're accelerating or they're at a constant speed. But again, this person can know that. This person has perfect knowledge that that's what happens, so the frequency change. So they have two things they can detect. They can detect how many photons are hitting them, and they can detect what the frequency of the photons are. And that'll tell them everything they need to know about velocity and all that kind of crap. And this communication, you can't change the time of it, because we know these photons travel this constant speed, and they're going to do it at a constant speed. So all this information is not going to get distorted by any bent space crap or any relativity crap or any perspective crap or any of that kind of crap. And so there's no way you can have these people dilating in time, because they're going to receive the information in descent intervals. The intervals are going to be spaced in time and distance. And so there's no need for this nonsense. There's no need to project this silly notion that this thing doesn't happen. Because we know this is going to be an optical illusion. Let's say I make their speed 3/4 of the speed of light. So instead of half, I make it 3/4. So this one's going 3/4 of the speed of light away. That's like me saying, 75 miles an hour and 75 miles an hour. Then we know we're over 100, 150. So if I use 3/4, this person's going to perceive this person as leaving faster than the speed of light. The calculator's going to say they're going faster than the speed of light. But they're going to know, well, that's only because of this perspective issue. It has nothing to do with the reality. They're not actually going faster than the speed of light. I'm leaving with half the velocity. They're leaving with the other half. That's it. This isn't complicated. Nothing's actually moving faster than the speed of light. This is like an argument where somebody talks about moving a laser across the moon. And I can make the laser go faster than the speed of light. Well, you really can't. Nothing goes faster than the speed of light. The only thing moving are your photons. Nothing's moving on the surface. There's no physical thing moving from here to there. Your photons are the only thing moving and hitting the surface. So nothing's moved faster than the speed of light. I mean, these are just logical arguments. And they sell this crap like it's all tight and, they've proven and it's all undeniable and you can't possibly think anything other than their crap. And the fact is you can think something better and something more reasonable. You can go back to, again, an argument Newton made. I mean, he made pretty aggressively. Newton believed in three-dimensional space. Okay? He believed this space was empty, nothing in it, and that there were things in it, and they were in positions in that three-dimensional space, and they moved in absolute space. There wasn't any, there could be a place where you could just say, I'm sitting there and I'm not moving. There was such a possibility that you didn't have any motion in any direction. That could happen, okay? Not likely, but it could happen in this, plane space model. But we already know that everything does seem to have collective motions. I mean, there's, the Earth is doing this, the Earth is doing that, the Earth is moving around the sun and the moon and the Earth are all going that way, and they're inside a galaxy going this way. And the fact is, though, is if you think about that, if you think about all those compound motions, you have to recognize that for every motion that causes something to go this way, there's that sort of opposite effect where now you have less stuff going that way. You have an imbalance created because the universe has an equal amount, you could argue, and that creates the symmetry we see. And so that, if I've got something moving this way, I can figure that somewhere else in the universe there's a that way. And so you can understand that there's all kinds of likelihoods that any motion you've acquired one way, there's something else moving the other way, and maybe you're part of something moving the other way, because all of it has to balance out in the way. Everything can't have a bias in the same direction. There has to be the other stuff going the other direction, so you can understand that it would end up compensating for each other, and your net velocity might be almost nothing, because the fact is the galaxy is turning in a different direction than the Earth is turning, and this is turning in, all of that crap. So you don't have to believe that motion is relative. And again, they haven't demonstrated that you can change my heartbeat and change how the photons are hitting me from the universe. I can't change the photons, right? The photons, as I'm moving, there's photons hitting me. I can't change that. I can't physically change the universe and make more photons in it or make less photons in it. And that's the only way you could time dilate, is you'd somehow have to suppress the rest of the universe. The rest of the universe can't hit you with any photons because the rest of the universe has photons in it. They're moving through space all the time. You're going to move through that space. You're going to have to interact with those photons. So there's that energy. So there's no way you could be time dilated because that timing signal is always hitting you and heating you. It's always making you part of the universe again. So you can't go into some special state where you can sit there and pretend you're in, cryogenically frozen, and you're not going to blink at the same speed, and you're going to move slower, and all this bullshit is going to happen, and somehow you're going to age 1,000,000 years, and something else standing still isn't. You're in the same photonic gravitational universe. The universe is full of energy. You're both in that universe. You both can't age at a different rate because your aging rate is based on how much energy is hitting you, how hot you are, how all these things you are. You can't separate yourself from that fucking physical universe. You can't escape that. Those minute little particles. They're constantly flying through everything. Gravity doesn't care about a glass globe. Gravity doesn't care about a thermos. Gravity doesn't care about any of that crap. You can't make stuff float by just putting it inside of a vacuum chamber or something. That ain't going to happen. You can't defeat it. I mean, you can defeat it, again, in ways that would only fool the ignorant. In buoyancy, in a fluid or something. You could suspend something in a fluid or some other thing where you're relying on its buoyancy relative to other matter. But I'm just saying you can't take something in empty space and just make it float anti-gravity wise. The only way we can make something float is we have to create magnetism, all kinds of other charge effects. We can't make something float by breaking gravity. We can only cause a new fuel to push it against the gravity. All right. Let's see, do I need to go much further? That's 30 minutes. That's longer than I like these videos to be. Well, this is a different video, so it isn't one of the short videos. But yeah, it's a look, they like I said, they make it much more complicated than it can be, and I'm just suggesting to you, you should just think about whether you want to be a dupe or not. I'm just telling you there can be simple explanations for things, and the physicists aren't looking for them. They're not looking for a simple explanation. They're not looking for an explanation that doesn't have 1/2 mv squared in it. They're not looking for an explanation that doesn't have some idea of bent space in it. They're not looking outside of that box they've already built, and it's a crappy box. It's not a simple box. It's not what you would expect from a mechanical system. A mechanical system has to get simpler. The parts have to get simpler. It can't be made out of hoobies. There's no hoobies in the universe, making things happen. There's simple things in the universe. And the simplest you get is we understand the two matter bits. They can't draw you where neutrinos are hiding. They can't draw you where positrons are hiding. They can't draw you where taus are hiding. They have 400 particles they say that exist. Where are they right now? Right now, where are my taus? Where are they? I mean, it's a nonsense theory. We know the electrons and protons are there. And the neutrons are just an electron and proton stuck together. I mean, duh. It decays into an electron and a proton. Obviously, that's what a neutron is. It's the smallest dipole. It's what you make magnets out of. All right. Yeah, I think that's enough. Yeah, I won't bother with part 2. He's not gonna prove anything. He's just gonna do the standard math and tell us this is how much it's time dilated. Even though the universe is hitting it with the same stuff, no matter how fast it's going, it's still getting hit with the same total stuff. They're just going to pretend that somehow getting hit by the same total stuff means you can possibly age slower and function slower, that your atoms can interact with the universe in some slower way, even when the same speed of the same amount of little bits are hitting you. Somehow you can escape time. Time is just a function. There's no such thing. As Newton pointed out, there's 3 dimensions. And the three dimensions are defined by having 90-degree angles to each other. There's no room for a fourth dimension, so it shouldn't even be a concept in the first place to talk about fourth dimensions, because they're not connected to the three geographical dimensions. And time is just a function. Time is just a byproduct of the fact that those little Sisyphuses that are pushing the electrons and protons around, they don't go instantaneous speed. They're slow. Yeah, the speed of light is a slowness. And that's why there's time. But that's it. Things can't travel distance instantaneously. That's why there's time. It's not a dimension. It's a function. And a function really nailed down to a very specific time. That is the time it takes for us to travel distance. And it happens very precisely. Photons are very precise. They're very reliable. You wouldn't even be able to have a cesium clock if the speed of light wasn't so frickin' rigid. All right. Because the frequencies are huge, billion cycles a second kind of stuff. I mean, it's just so fast. And any tiny fluctuation in the speed of light would mean the thing can't work. All right. Enough of the video. Find my mouse. Okay. So, till the next time and such and so forth and whatnot.